Welcome to the Small Wind Site Assessment portion of the Introduction to Wind Energy course. I'm Chris Folk. I'll be going through this slide presentation here. This is the first of 10 modules which we'll be going through in order to help us writing our wind site assessment reports. We'll be discussing many different parts of this in this introduction section. But first I'd like to make sure that I mention that you realize that this slide presentation was adapted from the Midwest Renewable Energy Association course called Wind Site Assessment. Its number is W201, and that is an online course. So many of these slides have information about doing this class completely online with submissions that can be done electronically through a system that we do not have access to. It was developed with a partnership between the MREA, Focus on Energy, and three other individuals, Mick Sagrillo, Sam Simonetta, and Jenny Heinzen. So Jenny and Sam, friends of mine, were the ones that put this together, and it was reviewed then by Chris Talbot Heindel and Clay Sterling, who helped fix some of the lumpy spots, and it turned out really well. So what we want to do is determine, just what exactly does a wind site assessment mean? And why is it so darn important? And what are we going to do with the report? So as an outline of what we're going to do in this content, we're going to define what small wind is. We'll talk a bit about what we're trying to do with the course and the expectations, what you'll be expected to be able to do when we're done. The MREA has a site assessment certificate program which has specific requirements. Some of those include taking this course, writing practice site assessments that will be graded by a mentor, specifically me most of the time, and I will give you those assessments back, and you can make corrections on them, and once those have done, you have the opportunity for an extra fee to take the exam and gain a certificate from the Midwest Renewable Energy Association. So we'll talk about what's supposed to go into those site assessments, because obviously we have to be able to grade you based on things that we expect to be in there, things that are going to be valuable to the many people who would be looking at those, from customers to installers to perhaps politicians, perhaps government agents that would be trying to determine if it was a good place to put the turbine. A lot of things we'll be getting to momentarily. And some of you may have experience doing solar or PV site assessments, and for those of you that do have that, you'll notice the template and the reports are similar, but they're not exactly the same, and we'll talk about what some of those differences are. So the focus on this is specifically to be small wind energy systems, which would be less than 100 kilowatts. And most of the time we're going to be even less size than that, which would be 20 kilowatts. And the 20 kilowatt comes from, here in Wisconsin, we have a PSC document that is going to limit the size of our turbines for residential use to be less than 20 kilowatts. That happens to match the net metering rules in Wisconsin, which of course, as you remember earlier in the class, we talked about some communities and jurisdictions having even less. We'll use a template. That template is going to serve as a guide. Pretty much we're going to do some cutting and pasting. We're going to be modifying the existing template to fit the information that we have. We'll be deleting things that don't apply to our report and adding things that maybe aren't in the existing template. We will not be including what's referred to as VOTs. And a VOT is a vertical axis wind turbine. We will also not be using rooftop turbines. Those are turbines that get mounted on the roof of a building, things that could get put on really short towers, or things that are referred to as building integrated wind. These types of towers, and turbines don't have very good performance as measured by many testing organizations. And so what ends up happening is an unwitting customer would buy a turbine, one of these that fit in this category, and they would put it on their home, and they would be vastly disappointed with their return on investment because, for the most part, these machines that are listed here, they're not worth the money. They do not perform or generate energy sufficient enough to be worth the investment for the most part. Most customers would like to put in a wind turbine that generates energy and electricity that they can use in their homes to offset their electrical use, or to some even have ideas that they'll be able to sell electricity back to the grid, and we'll talk more about that as well. So again, the focus of this course does not include large wind turbines, 100 kilowatts or larger, or any sort of commercial utility scale installations, wind farms, and so forth. We're typically talking about the small things that a typical homeowner or farm owner might want to put on their property. This is what we're going to cover. Look at that. First thing we put is load analysis and energy efficiency recommendations. Why would we do that? Well, as you remember from earlier in the class, if I can reduce the amount of energy I need, I can get by with putting in a smaller turbine. We have to talk about the electric service requirements. What do we actually need? How do I connect to the grid near me? Is it a single phase voltage? Is it a three-phase voltage? Is it getting to my home overhead, or is it an underground? Next, we have to look at the property itself. We have to figure out on the property, where could we put it? We'll have to figure out how high we should put them. And there are some minimum acceptable tower heights. In different regions of the country, you can get by with smaller ones. In other regions, you'll need taller ones. And that's based on some of the surrounding elements, whether that's a home or a building, a silo, trees, and so forth. We'll have to determine the average annual wind speed at the height of the hub. That's the center of the rotor. We'll have to try and determine what the site's wind potential is. We'll be recommending turbine sizes and tower types. Notice I didn't put down turbine manufacturers. That's not our job here as a site assessor. We're trying to determine how well the wind will work at a particular location, and to match a turbine to the customer's goals and expectations. And with that, we have to be able to estimate, well, just how much energy do we think we're going to get out of this? If we put in an estimate that vastly exceeds what the machine is capable of producing, we will likely end up with unhappy customers, and this can cause a lot of problems. So we want to make sure we're maybe even conservative rather than optimistic when we're trying to determine how much output we would get out of a wind system. Lastly, we have to talk about some ballpark cost estimates for the wind systems, and this is going to vary quite a bit. Because there aren't many wind turbine manufacturers to select from, and the technologies on these, although similar, the approaches are sometimes different between the different manufacturers, and so their costs are different. And their mounting types are different. And then, of course, we need to talk about next steps for the clients, and we'll see where that fits in the reports that's in the template. Hey, I expect you to participate. I expect you to do the homework. If we have some field exercises that you're supposed to go out and do by yourself, I expect that you do that. If we were to have any sort of a field trip, I would expect that you would show up. I think it's a good idea that you take notes as you're listening to this. Some of you, I will be posting the PDFs of this presentation that you would be able to take some notes on if you felt like. If you have some questions, feel free to post them on the Blackboard discussion board, or send me an email specifically. You could ask me a question about something you're unclear of, and I will do my best to respond in a timely manner. Turn your stuff in on time. Always a good idea. I understand life happens, and we don't always get things done on time, but the farther behind we get, the harder it's going to be to cover all the material that we would like to get done. So this next bullet's kind of interesting here. Use good judgment and common sense. Boy, you can't teach that. You can't teach that at all. wind side assessment is not exact. There's a lot of guesswork involved with it. And by comparing it to what a PV or a solar electric site would be, it's a lot more cut and dried because we have better models and better understandings of where and when the sun is going to shine at a particular location. And by that I mean it doesn't really matter a whole lot whether the PV is mounted on the roof of a piece of property or 100 feet in the air. It will make a huge difference between mounting a wind turbine on a short tower, maybe 30 feet, or on a tall tower over 100 feet, perhaps over 200 feet. So this assessment is not like a PV or a solar site assessment, and I will be stressing that several more times. There's a thing about netiquette. So when we're online, if we were to do in some online coursework, it would be possible. Sometimes this course is delivered in such a way that we're all online at the same time, that we meet at 8 o'clock at a particular night. This course, as I'm delivering it, is not set up to be that way. But if you ever are involved in some of these, there's a thing called netiquette, right? And so that netiquette, just remember that everyone out there who's whether they're typing something or if there's voice and video involved, hey, there's a person there. And so think about what you're going to type, think about what you're going to say, and would you say it to them to their face? We have to be respectful of others' opinions, whether we agree with them or not. We would like to try and avoid sweeping generalizations. People who say things like this are X or are Y or don't know this or don't know that. If somebody says something and in their explanation it's a little bit clear, you can think about it for a minute, but before the topic moves on too much further, you might want to ask a question. It's easy to say, well, maybe they'll get to that in their next section. And you'll gain a feel for the other people that you're online with. And it may be quite possible that one of these people or some of these people do introduce a topic early in their discussion and then fully flesh out what they're talking about. And if you were just to wait a couple sentences later, you wouldn't have to ask the question that you asked. In the MREA's online coursework, everything that is selected, they have several online quizzes and requirements that need to be done before you can move on to the next chapter, and so every click is recorded. We do not have that set up for the Madison College version of this. I, as many of you know, like to be funny, and they're sometimes too sarcastic, and that can be very easily misinterpreted online. I have to be careful when I'm doing this. Even with just this voiceover stuff, I can be misinterpreted, or when I look back, I think about something I said and maybe I could have put it a different way or maybe said nothing. Always review your work before submitting. Look at that. I should have probably reviewed this before I put it online. We want to try and avoid acronyms such as that we would use for texts. Other acronyms we would use, like the Small Wind Certification Council, we'll see that, or NABCEP or the NEC. Those things we can keep. These that we see here, LOL and OMG, we're going to save that for text. Same thing with emoticons. Let's leave that kind of stuff out. Avoid using all caps because it means you're shouting, but that's really not the issue. It's difficult to read. It's more difficult to read an all caps sentence or paragraph than it is to read one with proper upper and lower case usages. Let's be polite. Say please, say thank you. Some of the things you will need as a small wind site assessor. You're going to need to have good writing skills. You'll need to have excellent writing skills. You will need to have excellent and solid computer skills. If maybe you're not so good at this, this course could be an opportunity for you to get better at it, because you will be writing some significantly long reports, and they'll be submitted to me, and I'll be reviewing them, and I'll be submitting them back to you with suggestions to correct errors, spelling problems, formatting issues. We want to make sure these are good documents. In addition to word processing, you will likely also have to use spreadsheets. Most will be using Microsoft Excel. There are others. We will also have to download, upload, and manipulate pictures and images. So we'll be downloading, for example, a satellite photograph, and that satellite photograph will show the layout of the piece of property with where the home is and any other outlying buildings and any trees or any other things that are important to the property. And we'll have to make some notifications there. We'll have to maybe put some drawings on there or some labels as to where we want the turbine to go, where the balance of the system is, where the service connection is, and so forth. These will be required not only for the reports, but they will be required by, well, I'm going to stop at that. So we'll need those for the reports. As I mentioned earlier, each of you will have to do 2 residential small wind practice site assessments. I will review those, and this is really important. Do the first site assessment and get it approved before you start on the second one. Because if you make a whole bunch of mistakes on the first one, submit it, and then crank right up on the second one, you may have to not only make the corrections to the first one, but then also have to completely rewrite your second one. Doesn't make a whole lot of sense. I can't stress this enough. I will expect a professional report. Okay? I'm not an English tutor. I'm not an IT specialist. Okay? That's not my job. If you need help with your writing skills, the college has several places where you can go and get that. If you're not very good at using Word or Excel or the uh, image manipulating software, then you may need to find some more help on that. I will give you some resources, and you'll see some examples in these videos, but you'll be on your own to actually learn and get good at those. And this is really a good opportunity to do it, this class. So in order to get a certificate, now notice that doesn't say certification, this says a certificate. And what the certificate means is that you have indeed met the objectives and qualifications of the coursework for this particular class. The MREA uses their Introduction to Wind Energy course, W101, as a prerequisite for the W201, which is the course we're going through right now. But you may also participate in the MREA's certificate program by taking equivalent coursework, and the MREA has approved what I'm teaching here at Madison College. You'll have to get a passing score in the final exam. You will have to submit 2 practice reports that are corrected and professional enough to go through. The current certificate fee is $50, and that may change. Now, I want to be clear here. It's not required that you pay this extra $50 in order to pass my class. You can get an A in my class just by doing the correct amount of work. You do not have to try to get your certificate. Please don't think that that's a requirement. There are some documents that you'll have to review in order to receive your wind site assessor certificate from the MREA. One of those is an assessor contact information, because they keep a list of site assessors that could be given out to people who are looking for them. And then there's also a code of ethics. The thing about the code of ethics is this. Mostly what this is about is that you are saying that as a small wind site assessor, you're not trying to sell this person any equipment. It's not your job. If you also want to be a small wind installer, you have to be really clear when you're doing this site assessment that you're not trying to push the models of turbines that you have. You are merely trying to let them know whether their property is valid and viable to put in a wind system. So, what is a site assessment? This top one is the most important. A site visit and analysis. You can't just look at the Google Maps and say, oh yeah, that looks like a good place. Oh yeah, how tall is that hill? How low is that valley? How close is the house here? No. It's not uncommon. I've gotten many calls from people who say, hey, I got this wind turbine that I had installed a number of years ago and it doesn't seem to be working or just doesn't perform very well. Can you come out and have a look at it? Most of the time I say no, but occasionally I have gone out to these sites and taken a look, and most often it's pretty obvious just by pulling in the driveway what the problem is. Where's the turbine? Oh, just barely above those trees over there. I could, if I wouldn't have known to look there, I probably wouldn't have seen it. So there are some things that that we will be looking for with our site assessments that that only boots on the ground will get us the correct information. So it's also a consultation for potentially interested clients. A person is thinking, hey, I think I'd like to put a turbine up. I wonder if this would be a good place to put it. A number of years ago, it was possible to have Focus on Energy pay to have a site assessment done for a piece of property. A customer wanted to have, was thinking, hey, I think I should put some a wind turbine up here, but I'm not so sure if it's a good place to put it in. And so rather than just call the guy who has one and see if he'd come over, a system was put into place so these assessment documents could be made. And um, currently, Focus on Energy is not funding any of those things. And so if a person is going to get a site assessment, they need to negotiate with you, the site assessor, what your charge will be for doing this work. We'll talk a little bit more about some values that I've seen on reports. Your site assessment is going to clearly document what your findings are. And you'll see as we start writing these, I do mean clearly, with photos, with measurements, with explanations, with charts and diagrams. And so this is going to be the first step that a customer is going to be taking if they're considering having an installation done. And one of the neat things is for us who really enjoy the wind is it gives us an opportunity to educate people. Now, many of you finished the assignments that I gave you in the last couple of weeks before and after the break, and where we talked about, what kind, geez, I wonder where I could buy a wind turbine. I wonder if I can find a used wind turbine. I wonder if I can find a new wind turbine. It's interesting some of the turbines that you found, and many of the turbines that were submitted to me that were found on eBay or on the internet that cost $600 from Missouri Wind or so forth. Boy, they sure sound good, but those are not. Those would not pass the Small Wind Certification Council. We're going to see some information on that in a minute. And so you guys are still learning as you're taking this class, and this will help us in finding better turbines and better machines. So when we visit, we want to see, is it suitable? Is the site okay? Is there a good place for it? How big is the lot? How close are the neighbors? Are there any obstructions and so forth? We also have to look at the existing electrical service and the infrastructure. Well, how does the electricity get on the property? Is it an overhead line? Is it a buried line? What's it rated for? Can it handle the amount of power that we'll be trying to put on this? Perhaps it's old, maybe it's fuses. So in some cases we're going to be looking at them and we'll be making recommendations that an electrical service be upgraded. We will talk about what a minimum acceptable tower height would be, and that will have a lot to do with this next bullet, what we expect the wind resource will be, and what that wind source is, and we're going to need to identify where we get that information from. And there's a Energy Periscope document or Energy Periscope website where we'll be looking, and a couple other sites where we're going to get good wind resources, just what we think the wind speed will be at a particular height. And there's no sense in putting a turbine on a short tower if it's not going to capture much energy. That makes about as much sense as putting solar panels in the shade to keep them cool. So we have to discuss what the loads are going to be met. Specifically, what does the customer have plugged in? What are we trying to do? What are their goals? Do they want to go off grid? If they do, there's a lot of extra things that would need to be done on a site assessment. If they do not want to be off grid, but are interested in connecting to the grid and perhaps storing some of their energy on the grid for when they're not using much energy but the wind is really blowing. So we have to take a look at what those loads are, which means visiting the property, walking around inside the home, getting the customer to tell us exactly what equipment that they have. And then once we know that, we can make recommendations for turbines that are available, high quality turbines that are available that can meet the demand, and get some approximate system costs. Notice that's in italics, approximate. There are many things that are going to be changed here. I mean, not changed, but there are many things that are going to determine what that cost will be. Some of the stuff we're going to hear as a site assessor, a person gives you a call and says, hey, I think I got a great spot for a wind turbine. You know, because man, the wind is always blowing here. It just blows like crazy. I can't. I get out of my car and my hat blows away, and you know, and I think I'm probably in probably the windiest part of the whole county, and because of that, you know, it's so windy here. I don't think I'm going to need a really tall tower. Maybe I can just get a shorter one because you know we don't want it to, you know, we want it to not look too bad. So you'll hear stuff like this. You'll hear stuff. I got this perfect place out there in the woods on top of the hill. It's awesome. It's way up there. It may also be, you know, 1,000 yards away, and that can cause some issues. This next one here is really interesting. When we look at nameplates, you know, if I go down to the local home improvement store and I want to buy a generator that I can pour gasoline into and pull the rope and get electricity where I'm at, or I want to be able to pull the rope and power my house if I happen to lose electricity. I can look at that and I can know that the capacity of that turbine, or I'm sorry, that generator, is the same thing as it says on the side. If it says it's an 8,000 watt turbine, so long as I've got gas in it, it'll be making 8,000 watts, right? If I leave it on for, if I draw all 8,000 hours out of it and I leave it on for an hour, then that would be 8 kilowatt hours for 1 hour. That's how much energy I would have created. Now, we don't get the same thing with a wind turbine, and why is that? Well, of course, because the wind doesn't blow at a constant speed. It's an intermittent resource. So we will, again, just like we said on the slide before, this is an opportunity to educate the customer and the consumer about, you know, how wind works. Here's one that we hear often on the phone. Hey, I was online and I saw this infomercial. Well, I don't think it was an infomercial. It looked real. Yeah, it was real. They got this new kind of turbine, and it does it catches all the energy and it kind of wraps it around the building and it funnels into this tube that pushes it through the turbine path, and it's going to make a lot more energy than anything else that anyone's ever done. As we've said, that's probably snake oil. It's probably not true. Probably doesn't work, and and one of the things that we've talked about is that, of course, we know it's not true because they have no data to back it up, or they have very little data, and it hasn't, or maybe that data hasn't been certified or verified by a third party that's unbiased. I could put it on top of my silo. I put all that weight in there, certainly it can handle it. That's not such a good idea, and of course many of you already know why. What about the old, you know, I've got my old water pumper there, and I took the sucker rod off of it. Can't I just connect that to something else and get electricity out of it that way? And then this is the last one here that some of you might recognize. I saw this $600 turbine at the store, and I think that'll work, or on the internet. So again, these things, yes, you can get a lot of things to generate electricity, but will it do it safely, reliably, and at a value that is worth the money that you put into it? So the kinds of turbines that we're going to be talking about, and we've talked about in the class so far, are going to cost a lot more than $600. And they're going to cost a lot more because most of the time we're going to be buying them and they're not installed. And so after you buy it, you have to have it installed. That might mean a crane, or it might mean cement. If it's cement, it might mean excavation. It might mean rebar. So when you deliver this information, when you deliver this report to your customers, you can pretty much expect a sticker shock. Okay. Now, I gave you guys 2 separate assignments. And one of the assignments was see if you can find a used turbine on the cheap, right? And then after that, I wanted you, now let's go back out and let's see if we can buy a turbine from a reputable manufacturer. And you should have already had an idea what that sticker shock is like. We'll look at pricing on many of these. A lot of your customers don't have a background in electricity, so they don't know the terms that we've used. They don't know what volts are. They don't know how to measure current or know that they're measured in amps or that power is measured in watts, or if there's 1,000 of them, that it's a kilowatt, or if I compare that energy use towards the amount of time that it's on, what a kilowatt hour is. And people don't generally understand how much electricity that they use. They know that their electric bill is $120 a month, but they don't necessarily know how much energy they used. Most people don't understand why turbines need to be so tall. Why can't I put it on top of the barn or the silo or that pole over there or even on top of the house? Couldn't I mean, that's a big tall building. Look, that's a 10-story building. Why can't I just put it on top of that? And so we'll be, again, instructing them as to why things like this are not feasible. And this one here is good. Well, what's a good price? How much should it really cost me? It's a really hard one. I mean, if you want to be sarcastic, you can say about as much as a car. Okay, it'll cost as much as a car. Well, what kind of car? What kind of car are you buying? You buying a Lamborghini? You buying a used Yugo? Are you buying? What are you buying? So we'll get an idea on what we can expect to pay for a 10 kilowatt turbine or a 15 kilowatt or a 5 kilowatt or so forth. The site assessment is really important because we have to get an idea of where the wind is coming from. How often does it come from? Well, the wind generally comes out of the east. No, I mean the west. I mean it blows towards the east from the west. Okay, so we need to get those terms right so that we can get it listed right and then make suggestions as to where to put the turbine. We'll learn about what's known as a wind rose that can be used in some of our wind estimate and our wind mapping tools. And that wind rose is going to give us a visual representation of how often the wind is coming from a particular area and how strong it is compared to other areas. The site assessment is important so we can talk about why tower height is important. And it's possible that we may have options, that if I put a turbine up at 100 feet, that my estimated output will be X. But if I put it up at 120 or 140 feet because it's allowed according to my county, then how much extra energy will I expect to harvest from that energy, from that wind turbine? And once we know that, we can then make a comparison to the added cost of going 40 feet higher in the air. Obviously, there's 40 feet more tower. How much more cement is there? How much more labor is there involved in putting it? There's certainly going to be 40 extra feet of wire to connect the energy from the top of the turbine to the ground. We have to be able to estimate the annual wind speed at the hub height so we can try and figure out what the turbine energy production is going to be. Remember, this is an estimate. It might seem odd that we have to know what soil type we have, but we do, because we have to make recommendations as to what kind of foundations are we putting in. I know there's areas up in the Adams County area that the water table is just 4 feet down. It's very high, a lot of sand there. So because of that, what extra steps are you going to have to take? Are there any requirements that are different than if, say, you're in a place that has a loamy soil? So we'll need to figure those things out. Is there anything in the ground? And so if the turbine is way over here and I have to cut a trench in the ground so that I can get the cable connected to where we're going to the grid or to the home, then I need to know if there's anything in between there. Is there a gas line in between one place and another because that's where the LP tank is at or so forth? Are there any setback requirements? Is the one place where the turbine will work best too close to a lot line? These are things we'll spell out in our site assessment. We want to try and help clients understand what the options are. So when we look at the data sheet from this manufacturer, we can compare that to maybe a data sheet by another manufacturer. They can get an idea, an understanding of what those terms mean. And of course, everyone wants to know how much it costs. Are there any available incentives? We all know, or hopefully we all know, about the 30% tax incentive available from the federal government and what you would have to do that. As of 2015, If you're going to install a wind turbine, it has to be in one of those that's listed by the Small Wind Certifications Council. Otherwise, you don't qualify for the 30% cash back. Now, don't be afraid to say no to somebody. What does that mean? Well, I'm not trying to sell them a wind turbine. They asked me to come and look at the property and find out, is this a good fit? And wind energy may not be a good fit for a person based on what their goals are, what their objectives were, why they wanted to put it in there, based on the property and the limitations that the property offers. Some people want to put a wind turbine up and it's going to work. I want to put it up. I have to have it up there. And they're willing to spend a whole bunch of money. And in some cases, that's their priority. You can buy anything you want. It's up to you. But we want to make sure that we make our recommendation that a site is good or is not good. We have to be honest and we have to be candid with them about the resource, what the production will be, and what the costs are. If we're clear on that, and if we're realistic and not over-optimistic, and the customer decides to move ahead, both you and the installer have that objective document that you created, your site assessment, that's going to prove that the customer made a conscious decision to buy and install that system. So what do you do when a customer says, oh, wow, okay, I guess I shouldn't put a wind energy system here? What should I do then? You might suggest that they put in solar panels. You could suggest that they spend that money that they were considering on added energy reduction, LEDs, ground source heat pumps. There's many things we can do before we spend the big money of putting in a wind system. The report itself has to be clear, well written, and professional. Look at all the different people who are going to read it. Obviously, the person who's writing the check for you, they're going to read it. Their family and their friends might read it. They may have to show it to the county clerk, the town board. They may have to show it to their electrical utility representatives. They may have to show it to anyone who's got any sort of incentives. The zoning and planning commissioners will want to look at it. If you're going to be borrowing money towards this system, the loan officer may want to see it. There might be a grant available if it's a farmer and he has a USDA grant available to him. Then that administrator would want to look at it. So this is going to be your name on it. It's pretty important. Most utilities have a requirement that you have insurance on your system so that your system can't take down the grid and then shut down your neighbors or cause damage. Lawyers may have to look at it, and also installers. The guy that they decide, I mean, you may not be an installer. All you want to do is do site assessments. And so then an installer is going to look at your recommendation. He's going to look at it, and he's going to try and determine whether you really knew what you were doing or not. And if you are, if you do a good job, it's not unlikely to have those installers ask you, perhaps maybe there will be another customer that they'll have that is looking for an objective third-party assessment be written, and but not from the actual installer. So that's who's going to be looking at them. What is small wind? Well, AWEA, American Wind Energy Association, they're saying that small wind turbines are defined as having a rated capacities of less than 100 kilowatts. 100 kilowatts and less. Down here, the source at the bottom says HCP. It's actually HTTP. So right down here, HTTP. I did slip the spell checker here. Sorry about that. This one didn't. There's another outfit that's known as the North American Board of Certified Energy Practitioners, or NABCEP. And they also say that a small wind system is defined as being either grid connected or an off-grid system that either has or does not have batteries, and it's 100 kilowatts or less. Now, I need to point out here that NABCEP had a small wind installer certification, not certificate, but a certification program that it was working on, and I was involved in that. And in the end of 2012, the decision was made that small wind wasn't ready for this certification program. Okay, so this was a little too, what's the right word? Aggressive. However, they are supposedly moving forward on a small wind entry-level program, and I will keep you abreast on more information on that. I understand that some test questions were recently written, and we may have extra things that we'll be able to do there. So the NEC also says that as individual generators can have a rated power up to and including with a 100 kilowatts. Now that was according to the NEC of 2011. Okay, 3 years later, the 2014 National Electric Code stated that it discusses, actually, it refers to all wind generators, regardless of size. So it used to be that there were things that the NEC didn't cover, but now they're covering all the sizes, which actually puts the onus on the smaller machines to have maybe some capabilities built into it that might be difficult to afford for maybe a 1 kilowatt machine, but very easy to absorb for a, oh, I don't know, megawatt machine. Now, there's one other organization that we want to talk about. You've heard me mention it before, the Small Wind Certification Council, SWCC. So they're saying that a small wind is a machine that has a swept area up to 200 square meters. And if you remember, we did some calculations here. 200 square meters is going to get me, I probably won't be able to capture or harvest any more than 65 kilowatts of energy. So there's another organization, AWEA, that we saw before, and they have some performance and safety standards that are listed here, and you can see the URL for it. And so this is how these are spelled out. Now, one thing that I haven't talked about, and I'm getting to, is one of the differences between PV site assessments and wind site assessments. Wind's standard test conditions is far less solid than the standard test condition is for photovoltaics. So here we go. This is an example of a solar site assessment. The cat knows if they lay there, their belly will be warm and their eyes will be shielded. So that is, obviously just kind of funny. But I would like to state that the sun doesn't change a whole lot. The sun shining on Wisconsin is about the same as the sun shining on South Carolina. What's the difference? Well, the difference is how much hotter it is in South Carolina and how much more sun they get because they're more to the south of us. But that can be calculated for much more easily than a wind resource. A wind resource, they're going to change drastically, maybe even on the same piece of property. And the biggest situation that we have to consider is the wind speed. How much different the wind speed will be at different heights. So again, standard test conditions, those were based on the temperature, the altitude, and the amount of sun that's falling on them, measured with an insolation meter, okay, measuring the amount of sun that's falling on. So those are pretty standard. PV has got many, many more manufacturers, and the costs between those manufacturers are all fairly, pretty reasonably the same, and they've come down drastically. So writing a PV site assessment is probably significantly easier than writing a wind site assessment. There are calculators that we can get from almost every PV manufacturer, whether they're manufacturing modules or inverters, even racking systems. You can go online, you can look on a calculator, you can plug in your address, you can plug in the number of modules you think you want to put up and where you're going to put them, and you can get all sorts of warranties and estimates on this stuff. Not warranties, you can get all sorts of production estimates, cost estimates, maintenance estimates, lifetime estimates, and that are pretty easy to compare with PV. Wind doesn't have that many manufacturers, and so we don't have that same good fortune. PV has 20 to 25-year warranties. You're not going to find that in wind. And why would that be? Lots of moving parts. PV just sort of sits there in the sun and works. So the SWCC, it's actually it's not a very old program. It's only been around for a little while. It's a voluntary program. Well, we say it's voluntary, but now that the NEC says it, your turbine has to be on the system. It has to be listed by the SWCC, or at least meet the standards that are listed by the SWCC. Uh, so it's soon going to be a non-voluntary program. If you want to put your turbine on the grid, it has to meet these standards, and this is the only outfit that's going to measure whether the standards can be met or not. So we know that the wind, it has a resource that's going to be site specific. There's only so much wind that's going to fall on this particular piece of property or go past this particular piece of property. And it will be of a different value at different heights. Generally, the higher we go, the higher the wind will be. And this can vary drastically on one single piece of land. This particular landowner may have hundreds of acres, and that gives you lots of opportunities or options as to where you would want to put it. And so because of that, you have to spell those things out. The output estimates that are based on a wind map, and I talked about this before, and a wind rose. So we'll be looking at that using a tool that's available to us in the later modules. We will also be looking at what's known as the manufacturer's power curve. So they give us some estimates as to what they think their machine will produce. Most manufacturers are going to say that this is a 10 kilowatt machine. And we're basing that based on a wind speed of X or Y or Z. And ideally, using this small wind certification council as the standard, we will perhaps get the manufacturers to all use the same reference lines, and that will help things out quite a bit, being able to estimate the amount of power that a system is going to put out. And then again, I can't stress this enough, because there are such a small number of wind manufacturers, their system costs are going to vary widely. And part of that is because of how they're going to be mounted, what kind of tower it's going to be on. And most of the manufacturers, well, many of the manufacturers don't sell towers, they only sell turbines. Some will actually, partner up, but we'll get to that in a bit. I mentioned what a power curve was. This is one that I'm using as an example. This is for a Berge XL.1 or an XL1. And I'm only picking Berge because Jenny had it on her slide here. I also have some experience. The college owns 2 of these, and we've installed it several times. So I have some experience using the Berge XL. It's a fine, it's one of the oldest wind turbine manufacturers in North America. They do a wonderful job. They stand by their equipment, and they have good reliability, and they are continuing to improve. But the point that I want to have here is that as I look at this, I can see when the wind speed is low, well, the power is low, right? So if the wind is only going 10 miles an hour, holy smokes, how much power am I going to get out of that Berge XL1? Wow, I'm not even getting 50 watts out of the thing. Well, if the wind picks up to 15 miles an hour, I'm going to get 200 watts. What's the wind blowing today? About 10 miles an hour. So that 1,000 watt, that 1 kilowatt machine is really only making 200 watts. And this is by putting this power curve in the site assessment report, we'll be able to explain to the customer very clearly that the only time this 1,000 watt machine is going to be making 1,000 watts is when the wind is blowing, holy smokes, according to this, 30 miles an hour. Now this is an interesting power curve, and this comes from North Dakota State University. And it's actually not the same power curve as Berge puts out. Berge says that their machine will make 1,000 watts at 24 miles an hour. Well, here at this location that was published back in February of 2013, this shows that this machine there must be some sort of obstacles. There must be that it's not getting, this was what they observed. So power curves are great for that. This is the label that will be put on turbines that meet the standards set aside by the Small Wind Certification Council. And kind of think this almost makes you think of a Energy Star sticker that you might see on a refrigerator or dehumidifier or anything else that uses energy. And so notice here it says sample wind power company, small wind turbine that runs at 240 volts, 60 hertz. So um, as of yesterday, there were 9 turbines which had met and been certified by the SWCC, and there were 4 others in the pipeline. Now, I want to point a couple things out here. And notice it's stating here that the rated annual energy is based on what? It's based on an annual average wind speed of 5 meters per second, which is about 11 miles an hour. And that the wind has what's referred to as a Raleigh wind distribution, which is as you recall from earlier in the class, it's a probability of when the wind will blow at different speeds based on bins or based on actual measurements. And so 5 meters per second, if this machine was listed as a 10 kilowatt machine and they did the testing on it based on 5 meters per second, this is all the energy it's going to put out, 12,000 kilowatt hours. What's that going to do for you and your customer? So this is really, really handy to have. If the customer wants to put in a wind turbine and they want to know what it's going to do, well, if they buy one of those snake oil ones that you can get off the internet, off eBay, that only costs $600, how do we know what energy it's going to put out? If it hasn't been tested by the SWCC, then we're going to have to just trust them on their word. Notice there's also another section that they're going to test. They want to check to see how much sound this machine makes. And here is another standard. So here's our standard test condition. That the sound level is not going to exceed, will not be greater than this 55 dBA audible 95% of the time. And that is going to assume that we have an average wind speed of 5 meters per second. Again, it's a Raleigh distribution. 100% availability. What that means is I haven't got it shut down because it's broken, or I shut it down because it's in a migratory area and I don't want the geese flying by to get hit by the blades. But notice also it says the observer, where I'm measuring this sound level, is going to be 60 meters or 200 feet from the center of the rotor. Well, let's keep in mind that we also have the height of the turbine. So if the turbine's hub height is 140 feet, then I need to walk at least 60 feet away from the base of that tower in order to measure that sound. If I'm closer, and sometimes even further away, the sound may be greater or less. So this is where it was measured from, which can be pretty important. And lastly, the rated power. Yep, the nameplate says it's a 10K machine. But after testing it, the SWCC said, well, I don't care what you call it. It only made 9.5 kilowatts, but which obviously doesn't bode well for the manufacturer. But it may also be that they turned it in and it was actually only rated as an 8 kilowatt machine. But after testing, it was determined, wow, this thing really performs well. And when we do it in these conditions, we actually get 9.5 kilowatts out. So that's pretty good. And notice we've also got this label is the exact same label that you can find on their website listed here below. There's quite a few resources that I've referred to as we've gone through this course. There will be some more listed in the Blackboard. One of the ones that every year Home Power Magazine has a listing of the wind power machines, and some of these are greater than 100 kilowatts, some are smaller. There are many other places. We've seen some websites here along the way. There are books by Paul Geip, by Ian Woofenden. There's Wind Power for Dummies. There's many more books are being written about wind than had recently been put out. So there's lots of places where you can learn from this. Lots of articles and websites. Plenty of videos, YouTube videos, and so forth. We saw IEWEA, there's Distributed Wind Energy Association, there's quite a few places that we can get extra information. So I'll have an additional list available on the Blackboard as well. Here are some of the ones that we had talked about, and you can pause this and write these down as you would like to or not. And so this is the end of Module 1. Again, I'm Chris Folk, and I appreciate you having endured this entire talk. And with that, I will close this off, and we'll move on to the next module.